Okay, so here's part C. Okay, is that a subspace of V? What do you guys think? I made this a really messy thing on purpose. And all these messy polynomials, you think, oh my gosh, this is going to be so hard to figure out. But this is a trick question. You should already know the answer. It's not? Why not? Well, too many vectors, that means they're LD. It means it's not a base. The question is S a subspace of V? Is this a subspace of V? So we've got to be careful not to confuse concepts. If I ask you, yeah, okay, so let me just follow up on your point. This is a four-dimensional vector space, and I gave you 1, 2, 3, 4, 5 vectors. So we know that these 5 vectors are LD. But that's not what the question's asking you. The question's not asking you, do these things form a basis, or are they both neither? This is a different question. This is just the question, is it a subspace? And the answer to the question can be given with no work whatsoever. You just simply look at it and you will know the right answer. So if I ask you a question like this on the test, well, this is going to be like almost like a freebie.
Yeah, because it's a span, so it has to be a subspace.
Thank you. That's it. That's it. Anytime I form the span of anything, right? Doesn't matter what it is, doesn't matter how bad the polynomials are or the vectors. It doesn't matter if it's the span of whatever, it's always a subspace. And you can just say that. We don't have to stop and check closure under addition and closure under scalar multiplication. We can just say this is a span which we know from class is always a subspace. You can say that. If it's something we did in class and you want to cite the fact that we said it in class, that's fine. Just make sure we really did it in class. I've had students say, oh, we did this in class before. And I said, I don't remember that. And I was there every single day. In fact, I was reading all the notes on the board. So just make sure we actually did it in class. But yeah, so this is a quick one. It is a subspace. We don't have to stop and check anything. Now, let's say I follow up. Let's say I do follow-up. The follow-up question would be, find a basis for this subspace. By the way, can I find a basis for something that's not a subspace? If I don't have a subspace, can I talk about a basis for it? Not at all, right? Not at all. So this example B, this thing here, by the way, this is just a cubic equation. Should have pointed that out. This problem over here, this is just y equals x cubed, basically. It's just that graph. It's not a subspace, so it doesn't have a basis. I can't ask you to give me a basis for something that's not a subspace. As soon as something is not a subspace, it's not very interesting. Right? Linear algebra ceases to be a useful tool at that stage. So it has to be a subspace. As soon as it is a subspace, then I can say, find a basis for S. Okay. So, can somebody suggest how I would find the basis for S here? Yeah, I mean, okay, first of all, would it be correct to just say it's these 5 vectors?
No.
No, because we know that they are LD, right? It's too many vectors. So we know that they're LD, but they do form a spanning set because S is the span of those vectors. So by its very definition, S is spanned by these 5 polynomials. So the polynomials are a spanning set. The problem is they're LD. So what we need to do is throw some of these polynomials away. And again, as I said earlier tonight, you can't just throw away whichever ones you want. So we actually have to go to the trouble of building this matrix as Deshaun suggested in order to figure this out. So